All right, recording. This is Lab 5, Group 58, lab discussion.
Okay, so lab this week was all about friction. First question it's asking us to discuss is in the experiment of measuring the force of friction static and sliding kinetic, you're required to keep constant the speed after the carts start to move. Interesting. If that speed is constant, what is the reason that in the graph of force versus time, the force is not zero? If force is no zero, the acceleration is no zero, so the speed is not constant. What is wrong with this statement? What?
You say the grammar is incorrect there.
Hold on. Make sure I gotta read this again. Hold on.
That was a bit confusing.
If force is not zero and acceleration is not zero, the speed is not constant. What is wrong with this statement? I mean, is it asking like why the force isn't zero because it's already sliding?
I have no idea. It just asks what's wrong with it, which I don't know.
If force is not zero and acceleration is not zero, the speed is not constant.
Well, that's
well, acceleration is the derivative of speed, no, or velocity.
I think it's asking like, how is it that the force isn't zero but the acceleration is zero? Because like technically, if there is a net force applied, then the speed couldn't be constant. But I think it's because like you pull the cart with an equal force that the friction applies, that it does travel at a constant speed. So it is possible to have acceleration at zero.
Yeah.
That's how I'm interpreting it.
That would mean that there's no net force, which
right. Like the force you pull with is equal to the like kinetic friction force. So you're not accelerating the cart.
Yeah.
So wait, what is wrong with the statement then? It's just that.
I
think it's just that even though like you're applying a force that's not zero, the acceleration is still zero because the like force you apply is equal to the friction force. So the speed is constant. That's how I'm reading it. I don't know. It's worded a little confusingly.
Yeah, the wording kind of makes it strange, but I think that would be a sufficient answer to the question.
Okay. I agree with that.
Because there would have to be another force to balance it out. Otherwise, it would be accelerating. So
right. Next discussion question. Discuss with your team the design of the experiment to find the responses to the two hypotheses above. Describe what you performed. So talking about, I think these two bolded things, it's asking whether the coefficient of friction is dependent on the mass or on the surface area it's in contact with. So I said that the mass is independent and that the surface area is the dependent factor. And then the experiment I did to prove this was I pulled the cart first on like a table, and then I did it next on like a part of a couch. And I obviously got different coefficients of friction when I did that, but the cart had the same mass.
Yeah.
So that would also play a part. And then, yeah, I just wrote it right here. I said I also performed an experiment where I added mass to the cart. I put some like quarters on top of it and I tested it on the same surfaces. And it like, I got like slightly different coefficients for each surface, but I assumed it was most likely due to like some error because whenever you do the graph, like it's like really squiggly. So I just had to use the averages and stuff, but that's what I got.
I think when it says surface area, it's meaning like the amount of contact it has onto the surface, not like what surface material it is.
Yeah,
Yeah.
Oh, really?
Yeah.
like if you used it on a balance beam type thing, for example, if there was less physical surface contacting compared to doing it across a flat surface where the whole thing's
Yeah,
contact.
but
Oh,
I think you got it. For me, I put it's dependent on the mass of the object and then independent on the surface area. Because for the formula for kinetic friction, it's like kinetic friction equals to. Give me 1 second. Kinetic friction is equal to.
I think it's
Uh,
mass times the coefficient.
Yeah, or it's force times your force, your normal force,
Yeah.
right? Which doesn't have anything to do
Yeah.
with your surface area, but then the mass of the object does because normal force is mass times mg. So no, normal force is mg, which is mass times gravitational constant. So, and like since it's for kinetic friction, it's the amount of force you pull divided by your normal force, and since normal force is mg, that means that it's like inversely proportional. So an increase in like normal force would mean a decrease in like uh, the coefficient. You know what I mean?
dang, I must have read it wrong then. Oh, that sucks. So it's actually the opposite.
Yeah,
Yeah.
that's what I put. Mhm.
Okay. I can fix it later. Okay, question 10, it says discuss with your team the conclusions you got and evaluate the forcefulness of the evidence you presented to support the claims you made. So I don't know. Obviously my explanation was wrong, so I'll let one of you guys talk about this.
I basically, I mean, using the formula, you know, not
Yeah.
that I created, but that physics gave us. I'm pretty sure you're able to, like that formula already supports the claim that mass has an effect to your coefficient of friction, and then surface area does not. So, yeah.
Okay. That's fair. Was there a close good question? Oh yeah. So this one's talking about like running the program. So it says discuss with your group how to adjust the parameters of height and base of the ramp so that when you run it, you get a constant speed. So I think basically what I did was I set like the force of the kinetic friction equal to mass times gravity times tangent of theta. And then if you solve for theta, I got like 30.33 degrees. Obviously, it'll be different for you guys. And then just any multiple like y over x that would gives me that same angle like worked. So this was my graph before it like made it go crazy weird. And then after I got it to roll it up constant speed. Did you guys do it different?
Would
Hang
you
on.
use tangent or would you use would you want to find the hypotenuse? Because isn't like the cart is sliding down a ramp, right?
Yeah.
So you would want the friction force to be going like opposite of motion to keep it
Yeah.
constant. So I think you solve for just like the x component of the gravity force, right?
Right.
So
Yeah.
wouldn't you want to solve for like the force that's on the same angle as the friction force? So it cancels out, I think.
That
Honestly, I'm
would,
not sure.
that would make sense though.
I mean, I just thought like use tangent because that's going to give you some like value, like inverse tangent y over x to get some angle. And so when I found my friction force, which was like the normal force times the coefficient I used, divided it by like the mass times gravity, which was just 2 in the simulation. if I would set the height to like 1.17, which was my friction force, over 2, which was mass times gravity, I still got a constant speed. So I don't know if I did it like some roundabout way, but it did end up working. So, I mean, I'm sure there's more than one way to do it.
Yeah, there definitely is.
Yeah, the way I did it was like found the like friction force and then found what angle the gravitational force would basically equal that, I guess. So
Did
it
you
would
find
cancel
like
out.
what the friction force would be like on a flat surface?
No, like on the ramp.
Okay.
Like if it was sliding down a ramp like this, I found the frictional force basically going this way, and then the gravity
Yeah.
force would be going this way, so they would just cancel out.
Yeah.
That's what I
Okay.
did.
Yeah, I'm sure whatever I did was some version of that because I still got the same answer, but I mean, I know what you're saying. I'm trying to remember what I did. I know this part took me a little bit to figure out, but I don't know. Jeffrey, how did you do it?
I think I did it the same way as you, but I don't know. I don't know. My numbers are kind of scuffed. I'm not gonna lie. Yeah.
Well, I think that is it for the discussion questions. So
It's funny that this document says July 25th.
yeah, we got a
All the
long
dates are
time.
messed up.
That's funny because like the dates are either in summer, like the summer version, or like the
Or
fall
August,
semester.
like early
Yeah.
fall semester. Yeah.
And then like when you look at the test dates, or like I asked him, I was like, because I'm from California, so I'm like, oh, I'm trying to move out, right, for like summer, and I was like, oh, what is the test date for the physics test? And he's like, oh, I will change it soon. And he never, and then after that, he literally just like he just never responded. I was like, okay.
All right. Well, I think we're good then.
All
All right.
right.
End the recording if you want.